Hi guys, we're looking at our Khan Academy solving systems of equations with graphing for 1.1. All right, so looking at this, we're asked to find the solution to the system of equations. So we're given a system, remember a system meaning that there's just two or more equations, which will give us lines on our graph. So we've got two equations here, so we're going to be drawing in two lines. And then we're asked to not only graph the two equations, but also to, again, find the solution. So again, solution, three different types of solutions that we could see with systems of linear equations, right? First is if there's one unique solution, right? They intersect at one point, one unique solution. They could be parallel. Remember, parallel lines are going in the same direction, meaning there would be no solution. This would be one solution, no solution. Or, right, it's like the same line copied and pasted over top of each other, which is like infinitely many solutions. Every single point on one of those lines is going to be on this other line as well. So they all work. They're going on indefinitely because they're lines, arrows in both directions. All right, so three different options. Looking at this problem, because they want to know specifically what is x, what is y, right? Process of elimination, we're likely going to be looking at one solution, right? Because they want us to plug it in, what's x and what's y. All right, so our first step, right, like it said, was to graph. So looking at these two equations, I know some of us are like, ew, like this looks gross. There's a lot going on here. I understand. If you can recall, like take like a moment, take pause. What equation do we use for graphing? Because right now this is looking very busy. There's like a lot going on. There's a lot going on. We want to condense, we want to simplify this as much as possible, make our lives easier, as you know. So remember the formula that we use when we're graphing, whenever we graph, is going to be y equals mx plus b for linear equations, right? It's just like short and sweet, to the point. We've got our y-intercept and our slope. All right, so starting off the bat, looking this over, we notice that these are not in slope-intercept form because y is not isolated, right? This is called standard form, ax plus by equals c. So we want to convert this from standard. So step one, we'll say. I'm doing this like really slow. So if you're like Speedy Gonzalez over here, you're like feeling good, feel free to skim through the video to, jump to where you need help. We're going to go slow for the sake of those of us that need some extra help. So step one is to convert standard form to slope intercept form. All right, so what does that mean? We're just going to be isolating y. So we want to get y by itself, isolate y. Let's just do one at a time. So start with this first one, right? Draw a line. We remember, so we want to get y by itself, but notice it's not only y, it's positive 4y. So remember from integrated math 1a, we want to isolate this entire term before we can isolate the variable. So how do we do that? We're going to go ahead and move this 8x over to the other side. Remember to always include that line through the equal sign. It's just reminding us anytime we're moving something over, we have to use the inverse operation. Why? Because those will cancel, and then we move it over. So now from here, I'll just like write it over here. So continuing over here, we'd have 4 y equals, I'm just going to rewrite this so it's in the same form. So 8x and then plus 24. If that tripped you up, you're welcome to do 24 plus 8x, and at the end, flip them, as long as we know that, remember that slope is the coefficient, the number in front of x. All right, from here, we're so close. We want to get y by itself. We got to get rid of this coefficient of 4, right? They're being multiplied. So to undo that multiplication, we're going to divide both sides by 4. We'll get y equals 4 goes into 8 2 times, so 2x, and 4 goes into 24 6 times. So right off the bat for this first one, we could go ahead and drag these points, showing that we know the y-intercept and we know the slope, right? Rise over run, we know the slope. Let's go to the next one first, just so we can kind of like just crank these out, just get them done. So once again, isolate variable y. Before we do that, we notice there's a coefficient. We got to get the entire term by itself. So we're thinking, what is preventing this term from being by itself? There's this negative 7x. We want to get rid of. We got to do inverse operation to move it to the other side. Those will cancel. We'll have 7y equals 7x plus 28. All right, again, how can we isolate this y? We're thinking, what is preventing this y from being by itself? And we see that there's this 7 here. So we want to get rid of that 7. We're going to divide both sides by 7. Those will cancel. We'll have y equals 7 goes into 7 one time, so just x. 7 goes into 28 4 times, so plus 4. All right, we're so close. So we're not quite done, right? I know. We're like, is that it? Not quite, not quite. Let me see. Can I move these? Oh, I can. Okay. So first one, y-intercept is at 6. And then we're rising 2, running 1. Can I put it on that point? Oh, I can. I was going to say if we can't, we could do inverse. Remember, go down 2 and then to the left 1. Right? You'll notice it's still the same slope. Can I scroll? Oh, good. Okay. Next one, y-intercept is 4. This is where it's kind of easier once we converted. That was like the hardest part. If we're following along with steps, so we converted. So now step 2, what we're on right now, is just to graph. Graph using M and B, right? Remember we start with B, y-intercept, and then go to M. All right, so we just did the first one. Second one, it's kind of nice, almost color coding. 4 is our y-intercept. So we're going to go up 4. And then we're rising, so from 4, rise 1 over 1. Rise 1 over 1, right? Or down 1 to left 1, right? Down 1, left 1. So from here, we've got both of our equations graphed. Again, what is our goal? Not only to graph, but to also find the solution. Where do they intersect? What do they have in common? And as we can see, right, if it's not obvious, this is a one solution. It's would be this coordinate right here. Maybe, can I not draw? Oh, that's why. Okay, I can't draw on the map. Interesting. That's fine. It's cool. Anyway, right here, hopefully you can see our mouse. Right here, where it intersects. This would be at -2 for x. So always start with x first. So left or right. -2 and then up 2. So -2, +2. Look it in. -2, +2. Just double check. X is -2. Yep. Y is +2. And here we go. Yay! So reference this video. Go back while you're finishing up the problems. As always, if you need any help, feel free to reach out. But I hope this video helped at least for you to get started. All right, take care, guys. Bye.